Okay, in this lesson we're going to look at what a chemical reaction is and the types of chemical reactions. So in a chemical reaction we always start with chemicals. So one thing I like to do in the lab is blow up methane. So methane is natural gas that's made from rotting garbage, and oxygen is oxygen out of the air. So we call these our reactants, or the things that we're going to mix together. Now, a lot of people think when we blow things up that we're wrecking them or ruining or destroying them, but we're not really. What we're doing is we're rearranging them. So the CH4 and the O2 rearrange to make two new things. These are called the products. Oddly enough, when we burn things, we make tons of water, but it's in the form of vapor. If you hold a piece of glass up over a flame, you'll notice that water starts to condensate on the bottom of it. Don't hold it too close to the flame because the glass will break. But water is made when we burn things. Carbon dioxide is also made. This is what we produce. Notice everything that's on this side, the carbons, the hydrogens, the oxygens, are all over here. All we've done is breaking apart these molecules and rearrange them to make something new. Now you have to have the same amount of things on the product side that you have on the reactant side. And that's where balancing that you did in grade 10 comes in. And we're going to do this in our next lesson. One carbon there, one carbon there, 4 hydrogens there, 2 times 2 is 4 hydrogens there. There are 2 oxygens here, plus there are also 2 oxygens here is 4. 2 times 2 is 4 oxygens here. Now this is a lesson for later on, the balancing part. What we're going to do is take a look at the different types of chemical reactions. I believe there is around 34 types of reactions, but some of them are just subcategories of the 5 major ones. So we're just going to take a look at how you recognize the types of reactions. A synthesis reaction is when 2 smaller things add up to give a bigger thing. Some of the clues: no plus sign on the product side. Usually, an element plus an element makes a molecule. So what you have to be able to do is you've got to look for the patterns. So a synthesis means to build up. So smaller things building up to bigger things. A decomposition is to break apart. Some of the signs or clues: no plus sign on the product side, on the reactant side. So these two, 1 and 2, the synthesis and decomposition, are opposites of each other. So usually it's a molecule into an element and another element, but in this case it's just a smaller molecule. But it's usually molecule, element, element. But one big thing breaks down into 2 smaller things, no plus sign on the left-hand side. We have 2 types of what we call displacement reactions. In a single displacement, the single means a single element. It's always going to be an element and a molecule, and what happens here is the K likes the Cl and it's stronger than the Ag, so it's going to kick it out. So this metal is going to displace this metal. You can also have one where a non-metal element kicks out the non-metal element. Remember how you can tell what a metal is on the periodic table? It's to the left of that step ladder. So the Ag is kicked out and the K has stolen the chlorine. Now, sometimes students ask me, does it matter which one you write first? No, it doesn't. You can switch the orders here. So the difference between a single displacement and a double displacement is a double displacement involves a molecule and a molecule. Remember how we can tell a molecule? It's got more than one type of capital letter in it. What happens here is they switch partners. So the 2 metals are switching places. So the K is now with the Cl. And the Ca, whoops, I wrote the same element down here. I should have maybe Br here. So the K is now with the Cl and the Ca is now with the Br. Okay, I'm not balancing these. I'm just showing the patterns. Look for your look-fors. No plus sign on the product side. No plus sign on the reactant side. An element and a molecule and a molecule. Okay, so these are the patterns that you're looking for to be able to recognize your reactions. A combustion reaction is when we take something organic or carbon containing and we react it with oxygen and heat. They often don't show that triangle, which is the symbol for heat. Whenever you burn anything, you are going to make CO2 and H2O. Okay, so when you take something like wood, this one's methane here, but wood's also organic. Take oxygen out of the air with heat, you'll make CO2 and H2O. I always tell people to look for these things on the right-hand side of the reaction, and that will tell them if they have a combustion reaction or not. Or I say look for a carbon-containing material and oxygen. Now, there's another type of combustion, and it's called incomplete combustion. And when you don't have enough oxygen, and if it's incomplete combustion, you will make carbon plus carbon monoxide plus H2O. There's one I like to do with Bunsen burners, which they will use methane gas. I take an Erlenmeyer flask and I hold it over the Bunsen burner, and the bottom of the Erlenmeyer flask turns black because it's incomplete combustion, and you're getting black on the bottom of the flask. Your job is to go over this video once or twice, take some notes, make sure you know how to find these types of reactions, and there will be a worksheet where you have to identify the reactions. I always use the short forms S, D, SD, DD, or C. So those are the short forms that I use when I'm trying to figure out what type of reaction I have.